Questions. Are we free to call the potential of the Earth 1 plus 100 volts instead of 0? What effect would that have on assumptions measured of potentials and potential differences? So yes. So draw two pictures here. This is Earth 0 volts. This is Earth 100 volts. And so if, for example, we had some space up here which was 10 volts, all that would mean is that on the 100 volt world, that'd just be 110 volts. So it's just the ground, the Earth, is just our baseline. So the way it would change potentials is it would change all the other potentials by plus 100. But differences, the delta V would stay the same because the difference between 10 volts and 0 volts is still 10. The difference between 110 and 100 is still going to be 10 as well. So differences will stay the same. Potentials will increase by 100 volts. So that's part one. Part two, what would happen if you were on an insulated stand and your potential were increased by 10,000 volts with respect to Earth? So Earth, stand, U. This would be 10,000 volts. So basically, the idea is you have a whole bunch of extra charges on you. Those charges want to get off. They can't easily get off because you are standing on an insulator, and also the air around you is an insulator. Now, then at some point it gets down to, when you get started out talking about 10,000 volts, sort of everything is a conductor. So it's going to be a question of how good an insulator is, but the electrons will try to, the charges, positive charges from you, or the negative charges of Earth, will try to jump to the negative charges to even out the voltage difference. So you might see stuff like your hair stand on end or get a tingly feeling, but you should, ideally, you'll just stay at your 10,000 volts and it won't be a big deal. But then again, it depends on how good this insulator is. So ideally, you're just fine. You're at a different potential than the ground. Not a big deal because you are separated. You might feel some sort of force pulling you towards the ground. It wouldn't be enough to actually feel the, it wouldn't feel like you're being pulled to the ground. But the idea is that you have a whole bunch of difference in charges, just like you're going to have a parallel plate capacitor. One is positive, one is negative. The idea is these are just at a different potential, just like you are now at a different potential than the Earth. You are in effect a person capacitor between you and the Earth, holding two charges separated. So exact same idea. You become the capacitor. Why is the electron-volt often a more convenient unit of energy than the joule? For two reasons. One is it's smaller, and so when you're talking about small quantities, it's really nice to use an electron-volt. One electron-volt is 1.602 times 10 to the negative 19th joules. Electron-volt is also a measure of energy. It's supposed to be a V for voltage. So you can say work or energy, which is measured in electron volts, which is convenient because the formula, just using dimensional analysis here, you can say that the formula for electric potential energy is charge times voltage, which is also convenient that volts, the unit for voltage, V, is also volts, very similar. So it's useful for it's useful to understand the formula for potential energy due to voltage. It's also just a small unit, which is useful for measuring small quantities. Another thing is you can kind of sort of sometimes, you can't usually cancel out units, but you can sort of also cancel out the E or the voltage when you're doing formulas with electron volts. It's not entirely formal, but it works well. So it is convenient. All right, how would a proton-volt compare to an electron-volt? A proton is mass, blah, 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 of an electron, about 2,000 times. So the only difference between an electron volt and a proton volt is that the energy of an electron volt would be negative E times V. So negative E just being the charge of an electron. The energy of a proton volt would just be positive E times, where E is the elementary charge, times whatever voltage difference you have. So the only difference is, I guess they would be opposites, but the amount of energy that we're discussing would be exactly the same. And usually when we're talking about electron volts, we're talking about the positive version. So really, we're probably actually, whenever someone says electron volts, they're probably actually talking about proton volts. But because all we really care about is the absolute value there. And electrons are actually negative. It'd been more convenient for physics if they were positive, but such as life. So really, they're all the same, and the mass is irrelevant because it talks about amount of energy. The only time the mass would come and play a factor is if you have an electron with 1 electron volt, and you have a proton with 1 electron volt. Their speeds would be different because the electron is so much lighter, its speed would be much greater than a proton, even though they would have the same amount of energy. So that's the idea between those, and that's how I approach those problems. Hope it helped. See you next time.